Hello everyone, my name is Harshita and my project is titled Loan Detection Using Machine Learning. The main goal of this project is to build a machine learning model that predicts whether a loan application should be approved or not based on various applicant details. Every day financial institutions receive a large number of loan applications and manual processing can be time consuming and prone to human bias. Through this project, I automated the process using machine learning so that based on applicant features like income, loan amount, education, and credit history, the system can intelligently predict loan approval status. I'll explain each and every cell step by step. First, let's come to our very first cell 1. In this, I imported all the essential Python libraries like pandas, numpy, matplotlib library, cbond, cbond1 hot c1, encoder, logistic regression, decision tree, random forest, accuracy, recall, f1, and joblib. Next, in cell 2, I loaded the data set into pandas data frame and printed its shape, and the first few rows you can see the output here. Yes, okay, here's the output. Okay, next coming to our cell 3, I examined the data types and missing values to understand what cleanly would be needed. I also checked which column should contain categorical versus numerical data. Okay. Next coming to our cell phone, common code automatically looked for common target columns names like loan status label, target loan default approved flag, and no status flag. Next, in cell 5, I converted the targeted values y and into numerical 10 format so that the models can interrupt them. This was an important pre-processing step. In cell 6, I identify all numeric columns and categorical ones. This was necessary for building a pre-processing pipeline later. Next, in cell 7, I created two new useful features, total income and loan amount log. These features help the model capture better patterns. Okay. In cell 8, I created a column values with median, cells missing categorical values with most frequent value, one hot co in quotes. Feature scales, numeric data. These pipeline shows that cleaning, encoding, and sealing happen consistently in one step. Next, coming to our cell 9. Here are cell 9. This I split the data set into training and testing to evaluate model performance. Next, in cell 10, the data set had unequal load approval classes. Small to balance the training data. This helps prevent bias towards the majority, helps class in cell 11 and 12 respectively. Multiple classes models. I trained multiple classical models, decision tree classifier, random forest classifier. Then I evaluated each model using accuracy, precision, recall, etc. I also visualized confusion matrices and ROC curves for model comparison. Okay, you can see the output of both cells. I'm scrolling. Here's the cell, and yeah, here's the output for both the cell, as you can see. Yeah. Next, coming to ionic cell 13 and 14, I extracted and plotted the top important features from the random forest model using a bar chart. This helps to understand which features most affect the loan approval like credit history, total income, and loan amount log. Okay. Next, in cell 15, I used randomized search CV to tune random forest parameters like number of trees, depth, split size, leaf size. This improved model's performance and reduced overfitting. C. Yeah. Okay. Next in cell 16, our second last cell, I tried to import and trade XG Boost, which is a faster and more powerful algorithm. If the library wasn't available, my code handled that gracefully. In our last, not the least cell 17, I combined the pre-processing steps and final train model into a single pipeline and saved this. Allows me to easily load it later and predict new loan applications with reloading all processing. So here is the best among all the achieved strong accuracy and ROC-AU scores. Balanced performance between precision and recall after using SMT in my concluding project. Say that in this project I built a complete and toned machine learning pipeline for loan approval prediction. It handled data cleaning, features engineering and coding, balancing, model training, tuning and evaluation. Such a model can be deployed in real-world banking systems to automate initiate loan institutions make faster screening and financial institution make faster and more reliable decisions. Thank you.